Everyone, we are going to do intro to version control with Git and GitHub. And now that I've gotten the official, we are recording this introduction out of the way, we can all take a breath and relax. So before I dive into the lesson, I would just love to hear from folks because I think we all got a little experience with Git and GitHub yesterday. Well, actually, even before that, real quick, can people raise your hands if you have used Git or GitHub before coming to this class, or show an emoji or something? I see Kate, Derek, Marion, Cody, Josh, a couple other folks. Do any of you maybe want to speak on like your own learning curve experience with Git like prior to coming here, just to share with everyone else for whom it's totally new?
The For me, the basics were it got kind of weird. Like you're like, what's a commit? What does a push mean? I mean, but you can understand that once it got into like branches for me, like working with other people, that I still kind of don't understand. It gets really complicated but I would say the basics you'll get after just using it for like a week or two.
Yeah, I think you hit the nail on the head. I think after like 2 weeks, everyone here is going to be comfortable with how we are using Git for about 90% of this class. Um, Anyone else want to share their thoughts about sort of their learning curve who's worked with Git or GitHub prior to Platoon?
You just gotta do it. You talk about it a lot, but when you do it, you'll know.
Yeah. That is also, I think, great advice. A lot of this stuff, what you all will find, it's a little cheesy to say it, but it's like learning an instrument in that there's like a muscle memory piece of just typing and doing it. And for those of you for whom, yesterday was your first introduction to Git and GitHub, I'd love to hear like one or two thoughts. If you want to, if it works easier to raise your hand, you can, or honestly, you just feel free to uh, speak up. Anyone enjoy it? Like who's brand new to Git? Like this is awesome. I'm stoked. Cool. A couple people. Um, Anyone like, oh my God, what the heck is this? This feels like I'm learning Greek. Okay, cool. That's a pretty good balance. Yeah, and it's just saving your game, I think is another good way to put it as well. And everyone can see my screen, correct, with like intro to version control and GitHub from our curriculum. Perfect. Thank you. Yeah. So these are more advanced tools, like they're industry standard, so it's important to learn them. For most of this class, we're going to stick with the very basics. There are really, when you get to the group projects, as Cody, I think you were mentioning, Git really shines when you're developing software as a team. And to use the music metaphor, like for those of you who have played an instrument or played a sport, you know that the real fun happens when you do it with other people. Like practicing is fun, but when you actually play a basketball game on a team, that's the fun part. Like when you actually play a show in a band, that's the fun part. And honestly, it's the same thing with developing software. The fun part is when you do it with other people, as fun as it can be to write software on your own. I think at least. And that's really what Git is for. So in a lot of ways, it is not really going to come into its own until after the course. However, the group projects will be like an awakening because then we actually have to start using branches and stuff like that. However, it still has a lot of practical value for helping us manage our code and not lose work, like saving the game, like someone was saying. And there's a lot of really important concepts, and because it's such a core industry tool, we want to teach it. So there's going to be a lot of concepts and things that you learn here. But on the practical side, it will stay a bit more straightforward. So again, the goal here is pretty simple. We want you to be able to use Git with the project to save your work as you go, so that you can save your work as you go. And if you need to, go back in time. And the term for this is version control. And most of you have probably seen this in Google Docs. But if you haven't, I will show you very quickly. And this idea really kind of comes from this version control software. They probably implemented it a different way here, but this is incredibly useful, right? And in fact, I can say like original commit, my first changes. And go to version history here. And in fact, let's name this. And this is exactly what we are doing with commit when we tell Git what to add to stage to get ready to save. What we then commit in a chunk of saved work and give a message to. Just like I gave a message here, we can give our commits messages. And the same way that I can now go through this version of my document, that is exactly what we're doing with Git. And I wanted to check in, does that make sense? And do people have questions about any of this? Whether it's about Google Docs or Git, but hopefully Git. Cool. Yeah, and this concept of version control is incredibly powerful, and it's why it's like now showing up more and more and more places. Like I'm kind of into doing stuff with music, and I'm still waiting for music software to make it easy for me to go back to like different versions of my thing. The website GitHub. So Git is a command line program, right? I can open up a terminal. I'll talk a bit more about what a Git repo is in a bit. But if I go somewhere where I know there's a Git repo, and I'll explain how we know that in a second, I can use this program that I've installed on my computer, Git, right? And apparently I'm not even in one yet. And in fact, this, I was going to talk about this in a minute, but this is sort of the secret sauce. A Git repository is just a fancy word for a directory named .git. And so when I use the Git program here to try and run Git status, and I'll do it again, I'll show you all where I am. I have a code directory in which I keep all the different projects. And this is for the Code Platoon curriculum GitHub organization. So this is just a directory I made. And if we use the ls-a command, which lists everything in this directory, and the -a flag, which is flag is the term for an argument to a command line program that has a dash, 1 or 2 dashes in front. The A, I think it stands for all, but it lists files or directories starting with a dot. And the dot is just a convention. A file starting with a dot called a dot file usually has configuration stuff, and that's why we don't show it by default. And there's something here. I think this is from VS Code, but there is not a directory named .git. So this program Git, right? We've learned how to install stuff on our computer through the command line using brew on Mac. WSL folks will see using apt-get hopefully this afternoon. But you all are getting familiar with the idea of these package manager tools to install programs. And we know that this path here is an absolute path where this / is the root directory of my whole file system, and the user directory and the bin, I think short for binary, which holds programs that we can run and execute, which is why it makes sense that Git lives there. And we may have learned that most command line programs, you can add a -- version flag to see what version of the program it is. And so when I run this program Git and give it an argument, just like we give functions arguments, I get this message. And the error message sounds scary, but this is a good opportunity to start learning this stuff. It says fatal, but you know, the computer is not crashing. And it's telling me this is not a Git repository. And the reason is because this .git directory does not exist, and that's actually what creates a Git repository. And in fact, if I wanted to, we will not do this a lot in class. We will not create Git repos this way. But if I wanted to create a Git repo, I can use the init command. And now if I type git status, it says on branch main, all of a sudden Git is paying attention to all these files. If I run this ls.a command, this .git directory has been created. So if you want to create a Git repo in a directory, you can run git init. And then it does all this stuff, mainly creating this .git directory. And now it's a repo. But I don't actually want this here. For one thing, like, let me go ahead and just create a file really quick. Actually, as long as I'm doing this to show a little bit of an example. The git status command is your friend, and you should use it pretty much before and after every Git command that you run, which is what I still do to this day. And now there's all these files here. For the purposes of demonstration, I don't want to have to add all this stuff to my Git repo. I just want to add this one empty Python file that I created. So right now, Git is saying, hey, there's a lot of files in this directory, in this repository, but the Git program, I am not tracking them. You cannot depend on me to save them. So I'm going to say, Git, I want you to pay attention to that Python file. And now Git is telling me, all right, I'm paying attention to this new change, this file that you created, but it's not saved yet. You can think of committed as equivalent to saved. Once something is committed, it's in there. It's in Git. I'll talk about branches and stuff later. We won't do a ton of branching really, unless you want to until group projects. But the one nice thing about this is it does keep me from deleting it. Like, let's see here. I think. Yeah, so it does, like, adding a file does do some nice things. Like, note that even though I ran this rm command to delete the file, it still says, hey, this change to be committed is staged. Git is not letting me get rid of this because I told Git I want you to pay attention to this. But Git is also saying, hey, there's this other change. You actually want to delete that file. Do you want me to stage that as well? Most of the time, you will not have to use this restore command. It is useful to know if for some reason you add something and have not committed it yet, and then you change your mind. And note that what we're restoring is not the file, but we're saying, hey, this change, which just in this case happens to be actually deleting the file, but it could be adding a new sentence. I don't want you to track that change, Git. Let's unstage that change. And as always, we run git status. And now we're back to where we were. So let's go ahead and actually commit this. The commit command, there's two ways to run it. I'll show you the easier way first, and then we'll look at the other way in a minute. This is what's actually going to save it. The easier way to use it is with this flag -m. If I don't put the -m flag, it will open up a text editor and ask me to add a message, just like I did here with this message, this message, this message. That's all that a commit message is. But especially like for workflow reasons, and especially we can show you how to choose what editor to use. I would recommend setting it to Nano or VS Code. But especially, I don't do that most of the time because most of the messages I want are pretty short. There's a whole best practice around more longer messages for bigger commits. But dash M is short for message. And then if we put in quotes, whatever message I want. Now Git has told me, all right, we've made that commit. If I type git status, these other files are still not tracked, but I don't have anything staged. So that stuff is now saved. And for your final sanity check, the same way we have a history, a log of changes here, Git gives us a log. And I only have one commit. Git gives us this unique number called a hash to identify the commit, the person that made it, because Git is for collaborating when it was made, and my message. So that's kind of cool. This is probably a good point for me to pause and see what questions people have. And I'm more than happy to step through something again if people would like that. Andrew, yes, sir.
Yes, can we go straight from making the repo to committing it, or do we have to go through that laborious process of making it and then staging it and then committing it?
Yeah, that's a great question. So there's two different things you're talking about. Creating the repo that I did with that git init command. In a minute, I'm going to show you guys how we actually want you to do that, because you are not going to be creating brand new Git repositories from nothing. We've got Git repositories in GitHub. We want you to grab those, which is what you all did with Git clone yesterday. But I want to kind of walk you through this so you can see how this works. The answer to your second piece, the laborious process of adding and then committing, yes, that is what you have to do all the time. But the reality is, as you get more comfortable with it, it happens really easily. And actually, let me show you what that sort of workflow kind of looks like in VS Code, because I think that's really valuable to see. So let me make sure I know where I am. So I shouldn't have been doing this work really in this directory, but that's okay. So just for a sanity check, there's my foo.py file, git status. It doesn't matter what terminal I'm in, because the Git program is installed really probably for all users, but certainly for our user. And so we can run it anywhere. And there's nothing like specific to a shell session. And all that work, without going into too much detail, somewhere in here, like, is all the stuff. Like, might be in the refs. Yeah, I'm not going to try and dig around inside this .git directory, but the important thing to know is, like, when we commit, there's some text file in here that gets changed. And basically, Git is using a bunch of text files inside this .git directory for a little database. Especially when we get into the Git workshop, we can talk a bit more specifically about that. That's more in depth than we need to be right now. So the process, it's a little laborious, yes, but in practice, it's not too bad. VS Code has a Git extension. You can use it if you want. We kind of recommend people not to do too much with it, because there is a lot of benefit to practicing using Git on the command line. And to be honest, all of these visual tools are a bit of a mixed bag. So I'm not gonna worry too much about this right now. Maybe I'll briefly show kind of using the VS Code extension at the end. Or maybe if like a student or TA like really likes this, or there are other tools like Git Kraken that have like visual components, they can do a breakout session or something. But our focus is going to be kind of teaching the command line, because it's good command line practice as well. But so, yes, we have to do this stuff all the time, but the workflow is not as bad as you think.
Copy, thank you.
Yeah, and let me demonstrate kind of what that workflow should look like right now. And I need to remember how to do an F string in Python. I think that ought to do it. But it just wants a new line there. So if I'm writing some code, oh, we can ignore that. We can ignore that. So it is a good habit to get, if you see a squiggly, see what it is. This is telling me it wants me to add a comment for like best practice because I have like a formatter linter tool set up. This is telling me I should name this differently, which actually I will. That's not a bad practice. Anything that's a constant that's always the same, they want to be uppercase. But sometimes the squigglies are actually like syntax errors that will cause the program not to run. I'm going to run my program because I always want to make sure that it's running. Apparently the Python command is not found, which, considering that I just did this a moment ago, does surprise me. But I know for me, Python is alias to Python 3. So this probably maybe when demoing some bash stuff, I did something screwy to my system yesterday. The important thing is my program runs. I want to save my work. So you are going to want to get comfortable with the keyboard shortcut Control tilde, the little tick symbol to the left of the one button. Because otherwise it does become laborious to switch back and forth between VS Code and the terminal. You can do stuff like, let's see here, panel position. You can choose where you put the terminal. That is useful to know. Panel position, bottom left, right, let's put it there. Align panel, that stuff I don't mess with. Somewhere in here, there we go. So if I create more than one terminal, which I can do with this little plus symbol, which is great because maybe I want to be running the Python REPL in here, and of course inside Python 3. I can just have that open. And for some reason, maybe I like that up here. So you can grab a terminal and pull it up here if you want. And then you can use the same keyboard shortcut to move between different files that you have open in VS Code to move from your terminal to your code. I don't remember the keyboard shortcut off the top of my head because I use something called Vim keyboard bindings, but that is a really good shortcut to get used to. You know, if you want, you could split a file. Let's see here. Split up. So that's not the kind of split that I wanted, because that one I don't like. But if you like that kind of split, you can. The split that I like, that I think is the most useful, is split left and right. And there's a keyboard shortcut for that too. But now if I want, I could have this, a terminal here, I can have this here. I think I can even break this out into a new window, though I'm not 100% on that one. Some people, Mac people, I do recommend installing iTerm. I actually, sometimes I'll just be writing code in VS Code, and then whenever I want to do something in the terminal, just go to iTerm because I can alt tab it. WSL folks, I don't recommend that because as we discussed yesterday, it can be a bit confusing and you can end up by accident using a terminal that's not running inside your Linux VM. But let's bring the terminal back here. So This is a bit of a digression, but you want to get comfortable, however you do it, jumping back and forth between where you're editing code and your terminal. So I've made some changes. If I use the git diff command, I can tell it, let's look at what has changed. And Git's telling me, hey, this foo.py file has been modified. Hey, I added some lines here. Perfect. I want to add those changes. And I want to commit. So I've done that. Let's add something else. Let me make sure my program runs. It runs. Git status tells me I've modified my foo file again. Let's add it. Most of the time, you can just do git add dot. That will add all changes to all files. I haven't been wanting to put these in my repo, but honestly, git add dot is easier and will work fine for 90% of the time when you're writing code. Git status again to make sure I've added what I want and not what I don't want. And if I do git log, now I've got a history. So it does add a couple extra steps. Honestly, that is part of software engineering. And honestly, getting the practice of the muscle memory of this is useful. And honestly, a bunch of studies have shown that really productive senior engineers do work in really small chunks. And even if it is slowing you down, in some ways that might actually be helping, because what I also did here, it doesn't really make sense because this is just an example program, but each commit captures my program in a working state. So if I add a tiny little feature that works, that's complete, and then I commit it, then I always have a history of my program in a good state. And then if I have a bug, where absolute worst case, I just cannot figure out the life of me for what's going on, I can roll back to the previous commit and I don't lose very much work. And this whole habit is a really good habit to develop. It will slow you down in a bit, but it will also pay off because it will help you reduce the number of bugs that you make. Your commits don't have to be this tiny, but I would try to not make them too big. And really though, you should be running your program after almost every line of code you write. Okay, I see a bunch of questions. I'm just going to kind of run through the Zoom grid. And hopefully, I think it was Andrew that addresses some of the understandable concerns about like, hey, this feels a little onerous. It can be, and you will get used to it. And as you all will find out, a lot of professional software development has its more laborious parts, because in some ways we're still in like the stone age of computing and we sort of do a lot of stuff manually. But it is not as bad as you think, because the more you do it, it starts to become muscle memory. Josh, yes, sir.
Yeah, I have a couple questions. So, add it adds the change to Git, but commit actually puts the change into the log, correct?
Yeah, that is totally correct. If I make a change here, like let's say z equals 13. Let's say I wanted to create a new branch for some reason. this foo file is still staged. That is maybe not the best example. I'm not sure. Actually, I apologize. I thought I could come up with a better one off the top of my head. But it's like, yes, until your work is committed, it's not saved in Git until the end of time. Like if I run this git restore staged command, that has kind of taken the foo.py file out of being staged and added. And in fact, now if I run this git restore command, it undoes that change because I have told Git, I want you to take this file back to the last version you have saved, back to the last version we have committed for this file. So until you've committed, it's not really saved in Git. It's kind of like if we're baking a cake, we put all like the muffins and the cupcakes on the baking tray, and that's like adding and staging. But then when it's like in the oven and then they're actually baked, that's when it's committed. And so like, you know, once it's in the oven, like it's too hot, no one's gonna put their hand in there. But like maybe when everything's staged, I'm gonna like come by and like eat some cookie dough or grab a cupcake or something. That's not the best metaphor, but it's not a terrible one either. Cody, did you have a question?
Yeah. So when we're actually doing the like version control, like we're gonna go back to a previous commit, there's that address that you copied and pasted yesterday.
Yeah.
Is that what you would call that, an address? Like the code by the commits when you look at the log?
I see what you're saying. Yeah,
Yeah.
that's a great question. That is not called an address. That is called a commit hash. And
Hash.
what Cody's referring to is this long number here. And we don't talk a lot about like hashes or hashing, but essentially it's like you can write some math where like if I give my little math program like a sentence based on the numbers and letters in that sentence, it turns it into some sort of unique number using math and programming. And I'm a bit rusty on it, and there's a bit more to it than that. But the essence is that like this string of alphanumeric stuff is guaranteed to be unique. I don't know if it's universally unique, but it's certainly unique in our Git repository. And so I can use it to uniquely identify any one of these commits. And I think I'll show a bit later how we can sort of travel back in time. But that's called a commit hash.
Okay. So
yeah, similar idea.
You're going to show it later, but we use that to go back to previous commits. Just
correct. And in fact, I will just show that now, as long as we're talking about it. You probably won't do this a ton. This does get a little more awkward and it can get a little trickier. But it is really nice to have the option. Git has a command called checkout, which is a little overloaded. There's some newer version of this that I still need to learn, but you can use this to switch branches, which you won't have to worry about too much. And if you wanted to go back in time, if you have a specific commit hash, you can say git check out this commit. Let's go back in time to here. And Git actually modifies the files in my directory. Git will interact with the file system. But remember, we have this .git directory, and that's where Git saves everything. So I have not lost that work I've committed, even though Git has actually changed this foo.py file for me. And if we type git status, there's this interesting message head detached, and it's not worth going into too much, but like part of how Git works under the hood is, let me just get a quick diagram here to share. and I don't want to talk about this too much. But just to very quickly demo it. And then after this, I think what we'll do is we'll take a short break. And then I will walk through the workflow of like cloning an assignment repo and working with it, because that's a little different, and that's actually what we'll be doing most of in this class. So the way that under the hood Git kind of keep tracks of this history is with something it calls the head, because in the world of Git, stuff is in branches. And again, the same way that where did my Google Docs go? We'll just open up. Right? Commit, 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 commit message, commit message, commit message. When I check out different commits, Google Docs is modifying the document, but the history is still there. And the way that, I don't know if Google Docs works this way, but the way kind of that Git works is like each commit kind of points to the one before it. And as long as that chain is unbroken, you can go all the way back to the beginning and kind of construct the whole thing. But you have to know where the beginning is, and you have to know where the end is. And so the end is called the head of the branch, I believe. And I'm sure Google Docs has to know this as well. And because we checked out a commit earlier in our history, we went from here, our most recent one, to maybe here or here in the middle, right? We went from here, commit 4, back to like commit 2. The head isn't pointing to the top of the branch. It's been detached. And this is where Git gets a little more complicated and can take some time to get comfortable with. And you all will not have to do this very often. So do not worry too much if there's some confusion here. This is really good contextual information, and we'll learn more about it in the Git workshop. And it's really good to know how this works, but in terms of your day-to-day workflow, you will not be going like back in time in your commit history a ton. It is really nice, again, to have the option. And if I want to change something, I could do print adding this when I checked out an old commit. And if I type git status, files modified, right? So let's add it. If I want to get back to like the most recent version, I just check out the branch. And I know that the branch is named main because that's the default name of the main branch when you create a new Git repo. And notice, so Git is giving me a bit of a warning. It's saying, hey, if you do this, Adam, this change that you made, this travel back in time message, well, you want me to go here, but you've added something in the middle now, and that's too much for me. I can't handle that. I can go back to how it was, or I can keep this, but I can't do it on the same branch. And in fact, let's see. And it's giving me a hint here of how to get that work if I want to save it, using that hash, in fact. And this is a more complex thing that we don't have to worry about, but I'll show it just to kind of so branches we aren't going to use a ton. if I use the just command git branch, it shows me the different branches. Branched off main is where I added this kind of when I traveled back in time. But if I want to have that full original version, I can go to the main branch. And note that Git again changes the file system when I change branches, but my work is not lost because Git is saving it all in that .git directory. So let's say I want to create a new branch called trying something that might fail. And I do stuff, and it's like some fancy code that did not work. So I can do an experiment on a branch, and if that fails, you know, I'm sure all of you have had the experience of maybe like having to undo some code that you've written, and you can like end up introducing more bugs that way, making it worse. So the one good thing that you can do with branches that is relatively easy is try to keep your main branch in a good state. And if you want to experiment, or like if you want to rewrite code, sometimes making a new branch is a good idea, because raise your hand if you've had the experience of rewriting code you've written and then breaking it. Exactly. So with branches, we don't have to do that. When you want to rewrite the code, in fact, let's check out the main branch. Git checkout. The term for rewriting is refactoring, by the way. If you want to create a new branch, you need to add the -b flag, and then you give it the name of the branch that you want. When you create a branch, it basically copies over. It doesn't actually copy, but whatever branch you're on, it grabs all that stuff. So everything from main is here. So now I'm on the refactor my feature branch. I can do my stuff here, break my code, have it all be wrong, save it in Git with a commit message. Again, do stuff that is throwing errors. Right? Git status, git add foo.py, git commit tried to refactor my feature, but it's broken. Now git checkout main, my nice clean main branch where all the code is all working. I don't have to try and undo stuff and introduce more bugs, which is a common challenge. So that is like the one, I think, useful thing to file away in the back of your head. Like when you're working on something, if your code is working and you want to try and do something, or you feel like you need to fix something, sometimes like, you know, I'm sure we've all also like made backups of files and had like old code version 1, old code version 2. If you find yourself doing that, another thing to do is, you know, let's say I write this function and I'm going to not worry about this error right now. And then I decide, you know what, I don't want this anymore. I'm actually not using this in my program. Well, by the way, in VS Code, if you hold down Command / or Control /, it comments out the line, which is incredibly useful. You can highlight a bunch of lines, Command / on Mac or Control / on Windows, and toggle. And I'm sure you all have had code where you've got tons of commented out code or code that you're not using. The more you write code, the more that will make it confusing to read code. So now instead of doing that, that's fine to do a little, but if you start to have a lot, let's do this. Make sure that nothing is staged, that everything is committed that I want. git checkout old code unused function. I created a new branch with this code. I'm going to go back to main. I'm going to delete this. Now, my main branch that's got the working program, clean code, easier to read. Francisco or I aren't going to be like, delete this unused code. Software engineers get obsessive about it because on big projects with lots of people, that stuff adds up so quickly until you have so much code and you don't know what's used or what's not. Everything's organized. And if I want to go back and look at that code as a reference, well, I don't remember my branch name. So let's type git branch. Okay. I need to install it, but there's actually a script that will give you tab completion for branch names, which is great because typing the branch name out is annoying and it's a lot better to just hit tab. So I'll try to follow up with that to share. But now I've got that code I didn't use. And there is a nice little shortcut dash that checks out the whatever branch you were last on. So you can hop back and forth between branches with git checkout dash. CD dash actually also does that. You can pop back and forth between directories. So that's a great way to save your code without like having a giant mess of your program. This is also probably a good stopping point. And I'm curious what questions people have. If someone has your hand up and you want to ask a question, just go for it in case I'm missing anyone. There's a great question here that Andrew asked, can you branch off of a branch? You absolutely can, and people will. You probably, for you guys starting out, you probably don't want to too much just because it makes life a little complicated, but you absolutely can. You can branch off of branches,
And how would you do that exactly?
You do it the same way that you create a branch to begin with. We actually were doing it already because we were branching off of the main branch. The only thing special about the main branch is convention. Convention that we as programmers know, and you tell Git, like Git actually calls it the default branch, the very first branch that's created when you create a new Git repository. And you tell Git, this is what I want you to name the default branch. In the real world, there will be like a branch named like production, testing, staging, and production is the branch that gets deployed to the server. There's a testing branch, and that goes like onto like a server for testing the code. Staging is the branch for stuff that's ready to go for production, but maybe like the business people need to play with it to make sure the user interface is right so people can see it. So you'll have like a couple core branches, and devs will like branch off of, and then there's like a branch named dev for development. And so as a team, I'm working on a feature, I branch off of dev, I do my work. When it's ready, I use what's called a pull request to share it with everyone. People give it the thumbs up, give me feedback. We merge it onto the dev branch. And by doing it that way, all of you can be doing the same thing and working on your own features off of the dev branch, and we can avoid what's called conflicts. And then when the dev branch is ready, we can copy the dev branch. We can merge, in fact, is the term, the dev branch onto the testing branch and test our code, and then merge that onto the staging branch and so on. I haven't talked a lot about merging branches, but you can branch off of branches, and in fact, let's let me do a little change here.
Whenever you branch, you do need to switch to the branch you want to branch from, right?
Actually, the checkout command, when you use -b, that tells checkout to create a new branch, and Git tells us right here that we also switched to it. So whenever you create a new branch, it also checks out the term, the Git term. I think there's actually a switch command now for Git because checkout is kind of confusing, but I've gotten so used to it. The term checkout, like, you know, let me check out this video from the video store, or check out a book from the library. So you check out a branch, and that's switching to use it. And so this checkout -b creates the branch and checks it out, and it'll always do that. So that's a great question, and that one Git takes care of for us. And let me go ahead and add this commit.
Well, I meant like, so if I want to copy, if I want to branch from a branch and copy everything in that branch, I need to actually be in that branch to
Oh,
copy, right?
yes, 100%.
All right,
I
thank
see
you.
what you're saying now. Absolutely. Like the git status command tells you what branch you're on. When you create a new branch, it is always branching off of whatever branch we are currently on. Yeah, that's a great question. I misunderstood. Thank you for clarifying. And there's a couple commands to sort of visually demonstrate this. I don't use them a ton. I've showed you guys the
Adam,
git
I have
log
a quick
command.
question before you
Yeah,
move
what's
on.
up?
Sorry. I had to step away earlier, so I think I missed this part, but that -b on that last terminal command you put, that git checkout -b, following the -b, is that just the name that you're giving your new branch you're checking out to?
Correct.
Okay. And that's
Yeah.
and that is like you creating the branch and giving it that name. It doesn't have to already exist somewhere.
Correct.
All right. All right, thank you.
Yeah, you hit the nail on the head. No, thank you for asking. Yeah, folks, please definitely ask, especially like I know I can jump around a bit, so I'm always a fan of questions, double checking, clarifying, any and all. I don't know, are there other questions that people have just to kind of double check stuff? Okay, cool. I'll show this one last thing, and then I think we'll take a break and I'll go through a bit more of like the workflow of what of using repos with GitHub. But hopefully, do people feel like they're getting a little bit of a better sense of how this program Git works? A little bit? Cool. The main thing I think at the end of the day is, you know, with Google Docs, it does this kind of for us of like I can type more stuff. I can't really tell Google Docs how to chunk up these changes. It makes that decision for me. And by default, it gives each commit a message. But I can change that and I can go back in time. I can check out a previous version of this document. You can think of this document as being broken into little pieces where each piece holds a bit of it. And if you add them on top of each other, where each piece, you can see in green here, this is the bit that each piece holds. It just adds that to the last piece, and it adds this to the last piece. And this is very similar to how Git is functioning with commits and adding and committing, and looking at that log. Git adds an extra level of complexity with branches, which we will not have to use a lot for a while. And they do get complex, and Git is a complicated tool, but I think this is a good visual sort of guide and metaphor. And it's the same stuff here, except we have this long unique number called a commit hash. and I get to decide how it gets chunked up, and we have to do that manually. There is this nifty command. Let's see, where did we go? So I don't use this a lot, but there is, and this one is not sort of that interesting actually. There are some visual tools you can use to sort of like see the branching. I don't use them that much, to be honest, so I'm not that conversant with them. Let's see if I can find maybe one good one just to demo it. But otherwise we'll just take a break. So let's try maybe git log graph all. Yeah, and then I googled this just now as how I googled git log graph see all branches. I definitely don't know this stuff off the top of my head. So oh, decorate. So this is not the best. There are other visual tools that do this better, but just to kind of demonstrate, we sort of like have these commits. You can sort of see where this branch happens here and how it kind of branches off, but really like we have a couple floating around as well, but I always like grabbing stuff from the internet, to be honest, because there's a lot of good diagrams up there already. Just to kind of show visually this branching and committing, you can sort of get an idea with this of what this looks like. Or here's a fun one as well, if it gets big enough. We're not going to do a ton of branching right now, so you don't have to worry about it too much. Where each of these little circles represents a commit. And so you can sort of see the nifty thing here is if I'm like creating a feature off the main branch, Git doesn't have to like copy absolutely everything. It just needs to have these like little pointers going back in time to connect the links of the chain. What questions do people have before we take a break? Okay, cool. This has been, I know I went a bit all over the place with some of this stuff and talked a lot sort of about like digging into like some details of Git. And after the break, what we'll do is I will walk through the flow of cloning a repo and going through it. I think maybe just to wrap things up, we've talked a lot about Git. We do have one nice diagram in our lesson material. I realize I did not walk through the tutorial, though I went through the same steps with a slightly different process. So these are the 3 states that any file in a Git repo can be: untracked. When we do git add, Git tracks it, and that's called staged. And then when we do git commit, it gets committed. So those are sort of the 3 states that anything can be in. And like when you see the word stage, think staging area. Like you kind of put stuff there, but it's not meant to live stuff forever. You generally then you want to go and commit it. Why don't we just take until the hour? So from now until 10 o'clock Central or whatever time it is in your time zone. And then I'll walk through the flow of cloning a repo and doing some changes and setting it up and maybe doing like a pull request and stuff. And also if there's anything that people want to review, we can do that then. Sound good? Cool. All right. Thank you, everyone. Have a good break and see you on the hour.